Hi folks, in this video we'll discuss about the development features, mainly the suspend and resume. So that is like if I've got a couple of tasks and I'm working, let's say I'm working on first task, and if my manager suddenly asks, "No, you stop the work and you work on the other task which is very critical," how will I suspend all my activities I have done? Like, I have put all the debug points, I opened so many files, so many windows in my Visual Studio. How will I set aside all those things, work on another fresh task, complete it, come back to Visual, again come back to my old task, resume it, so that everything, my debug point, my windows, everything should open as it is, right? When I was working on that, maybe let's say 2 hours back or 3 hours back. So the context switching is very easy now in Visual Studio. Then we'll discuss about code metrics, which is again a quality tool which will help me to identify the maintainability index of my application, or rather I can say the health of my application. How how good it is to maintain, or how maintainable it is. Then we'll discuss about code analysis feature, which is nothing but a set of rules which will run against my code and gives errors or warnings saying that certain rules are not followed, like either naming conventions, design rules, performance rules, maintainability rules. So many rules, so there are total like some, I think, 220 plus rules available in Visual Studio Code Analysis. Then we'll discuss about code map also. So while debugging my application, how I can visualize my code flow using code map. So let me start now. So I logged in as Julia. Okay, so let me go to my work section, and I've got two works to be done. Then let's say I want to work on this task. Let me drag and drop it. Okay, and let's assume it's a bug or something, I want to fix it, right? So for that, what I will do, I'll go to my solution explorer, open so many files. Okay, so I open so many files. Then let me say I want to put some debug points. I'm thinking the issues might be here, right? Then let me open all the windows I want, like breakpoint windows, output window, immediate window, and also I'm going to write some code. Maybe let's say let's copy paste this. Let's say I'm writing code to fix the bug. Now my manager says you stop this work and you work on the other task, which is very, very important. So now I can't check in because still I have not really modified the code to fix a bug, or I have not properly debugged, right? So now let me go and suspend this. So I'm going to suspend this. So you can observe when I suspend, it does undo pending changes and it suspends all the classes, everything I have opened, right? Now let me go and say set windows layout, right? All the windows are gone. Here you can see the bottom, all the windows have gone. Fine. So let me go to team explorer and say I'll be working on this task. So let me put this into in progress state, and let me go and maybe open this file and do some changes. I can say, so assume that I'm doing some changes, I'm done. I'll go and either request review and do all those things and check in. So my previous task is done. So let's say this is going to take some, this has taken some 2 hours or something for me to write all the code. Now let me come back to my work and I can say resume. So you can see all the things, my debug points, all the class files I've opened, all the windows, everything is back. Now I can go and modify or do some more things, and I can go and check in. So I can see when some changes are done. Let me go and see. Okay, so I've done some changes. So where is that? Yeah, so maybe I can put some more changes, and now I can go and check in. Let me go to my work. It's done. Let me go and check in. So this is how suspend and resume works. So what I did, I started working on first task, then it was half completed, then I went and suspended it. All my windows, my files, everything was like suspended and saved in DFS. And when I've completed the second task, I came back and I said resume, and you saw like all the classes, all the windows, whatever I had opened before suspending was back. So with this I can easily do a context switch, right? Mainly for the developers, when they are working, when they are trying to fix a bug or something, so they're very much deeply involved in that, and suddenly if somebody asked to do something else, it's very difficult after completing the other task and come back and again go back into that area, I can say. So it's difficult for the developers to go back and uh, think or realize what we're doing 3 hours back. This was suspend and resume. Let's go to the next thing, that is code metrics. So code metrics is simple. So I have to identify the solution, then right click on the solution and say calculate code metrics. So this gives me the health of the application, and it is based on these metrics: lines of code, class coupling, depth of inheritance, and cyclomatic complexity. So based on all these 4 parameters, I get a maintainability index. Now I can start with my project, then drill down to the class level. I can see the maintainability index, then to the method levels. Okay, just for the demo purpose, I've introduced, I can say more code, more cyclomatic complexity, depth of inheritance, to show that if in real time, if I have lots of cyclomatic complexities, that is if else statements, while do statements, then my maintainability index will reduce. Or if I'm using so many classes, if I'm deriving from so many classes, then also my maintainability index will reduce. Or depth of inheritance, right? And obviously the lines of code, executable lines of code. So based on this I get a maintainability index. So the colors red, yellow and green. So red indicates not maintainable code, yellow indicates somewhat maintainable code, green indicates good maintainable code. And what is the range? It is 0 to 9 red, 10 to 19 somewhat maintainable code, that is yellow, and 20 to 100 is good code. And from this I can directly go to the method. So let's say I want to go to this method and see what optimizations can be done so that the maintainability index can be increased. So double click, I'm at the code, and you can see in this code I'm using so many other classes. So these are all class coupling, right? So I'm using so many classes, I mean, and the functions of those classes or methods of those classes, and I've got complex if else statement. So that is why my code metrics shows this mental index as 6, right? And I've got another one where it is somewhat less thing, right? And there are other green parts. Let's say if I go to this, it has got 4 complexity, cyclomatic complexity number. So if I go here, so I've got if else statements, and they're like 4 blocks. So that's why it's showing that. And if you see other, it says 980 and 125. So what it means is it's very complex. Using this I can even say I want to assign a task to my developer. I can create a work item out of this and say a task to modify this, or I can even raise it as a bug. It's very important, so I want to raise it as a bug and my developers has to fix this code to increase the maintainability index. Even that is possible. And this maintainability index is calculated using a certain formula which is available in MSD Insight. Okay, now let's see code analysis. So code analysis are nothing but a set of rules. So let me go to the properties and select code analysis, click on open, and you can see these are all the set of rules available, and they are segmented into different rule sets, I can say, or segmentations like design rules, naming rules, maintainability index rules, so many things. Okay, and even I can say this is, I want maintainability index is very important. I can say if my code violates these rules, show it as error. So even that is possible, and I can have different rule sets. I can save this and create one more rule set, and I can show this as a error for maintainability index. So maybe let me click on save, and we'll say it is custom rule set. Let it be here. Save it. Okay, now let me run this code analysis. Let me right click and say run code analysis for the solution. I can run it to the solution or at the project level. So it compiles my application and runs all the code analysis rules, and yes, here I am. So I can sort it based on the rule ID, rule name, file path, file name, so many things are available, categories. So I'm sorting out based on the file names. So starting with, and you can see it's getting for cal function.cs file. What it says, you should use, do not pass literals as a local parameter, as it gives information also. Okay, and if I scroll down and if I go here, avoid excessive complexity. So it gives me, and it highlights also the code here. You can see that it's highlighting. So what it says has a, this function has a cyclomatic complexity of 80. Rewrite or refactor the method to reduce the complexity to 25. So even it gives the suggestions for me, right? So same way for this method it is 125. Maintainability index of this total method is 17, which is not a good sign. So it gives me, it says that rewrite the method to increase its maintainability index, and yeah, it gives a proper information here. Below 10 indicates poor maintainability, and index between 10 to 20 indicates moderate maintainability, and index above 20 indicates good maintainability. So current is 17, which falls under this moderate maintainability, so that's why there is a warning. Same way for this, so this falls under, I mean, poor maintainability because it is 6, right? So like that, there are other spelling mistakes, naming conventions. You can see it says that AVG, so give a proper naming convention for that, right? So there's so many things which gives information, like even say usage, properly use that, performance related issues, like say for example I've used so many variables which are, it's like assigned but never used anywhere, right? So like this it gives so many informations. Okay, so let me go to the calculator application again, and let me say browse rules, then select the custom rule what I had given, and say run the matrix. So let's see what is the difference now. So you can see code analysis detected errors, and you can see that. So it is showing as errors now, that maintainability index, right? Because if you see that add mention for maintainability index, show it as error. So that's why all the maintainability index violations are showing as error. So this is how I can even customize the rule set. I can have my own rule sets, and I can define which should show as error and which should show as warning, and also I can choose, or I can say I can deselect other code analysis rules which I don't want. Okay, so this is about code analysis. Now let's see how to debug with code map. So now let's say I want to debug this application. Maybe let's not put the debug points also. I want to just run this calculator application, which is a very small calculator application. Then or before that, let me go back and go to the IntelliTrace settings. So to general, okay. Now let's start. So I can just click on the values and I can, now let's say I want to break it now, stop, pause it, then go back and see how the my code behind worked for all these actions I performed, right? So I can click on break all, right? Then I can enable code map here. You can see that code map. Okay, then let me start with the initial point, then start debugging. So let me step into the things. Now it says I clicked on add button, then you can see it is showing here, it is going to the through the method. Now it calls functionality class, then it calls add function. You can see that it's calling add function, right? Now if I similarly do the same thing, now it calls subtract function. Similarly multiply function. So I can easily visualize from main method it went to button click, then function add, subtract, button click. So this is code map where I can easily visualize how my debugging is happening, how the code flow is done, right? And the beauty of this is I can save this file and I can use it for my reference, right? So let me stop the debugging here, and I have this file, and it is a dynamic, it's interactive file, right? If I, let's say, double click on that, you can see the function opens, right? Or I want to go directly to this, it opens. So I can save this file for my later reference purpose, right? So this was code map. So guys, we discussed about suspend and resume, code metrics, code analysis, debugging with code map, and also I'll come up with videos on code lens and code clone features of Visual Studio 2013. So once again, thank you.